Welcome to Startup Technology Pitfalls and How to Avoid Them. I've included this clever animated GIF of the old Atari game Pitfall, where our hero kind of leaps through the jungle, avoiding the various traps, which is not unlike the life I live in this startup, which is, I mean, there's more colors and higher fidelity, but there's a lot of traps. And so this talk's going to be, the ones that we've seen thus far, how we've tried to mitigate them, and how we've done overall in a respective looking back over the last year or so. I know. And just like that, in true Microsoft form, PowerPoint has crashed and come back. I'm glad this will be lived forever. Okay, pitfall once again. So some of the pitfalls you can't avoid. The market can change. You can make bad assumptions that don't actually resonate with your customer base. You can actually never find customers. Other pitfalls you can definitely avoid. You can pick the right stack, the right cloud, the right data storage system to enable you to do whatever it is you want to do. And that's mostly what we're going to focus on. But first, who am I? Who am I indeed? There we go. I'm Bryan Short. I'm originally from California, so I say things like totally and for sure. I like to hang out at malls. I graduated from UCLA back in 2004, many, many moons ago. And then I came up to Seattle, mostly because I didn't like sunshine, but I also got a job up from Microsoft. And leaving college, moving to Seattle, it sounded like a great way to spend the next couple of years. 9 years later, I left Microsoft to join a social analytics startup that I'll talk about in a second. So I've been here for 10 years now. It's a little longer than the 2 years I planned on. At Microsoft, I started an office, mostly Office Server, on a product called InfoPath. InfoPath is most famous for being the review tool that Microsofties would use once a year to talk about how they performed the previous year. So when you mention it to Microsoft people, they tend to have nothing but positive memories of using this product. After about 5 years, I kind of disagreed with how Office was shipping. They had a very typical waterfall model, which meant they planned for a year, they code for a year, then they fixed bugs for a year, then they hit the shelves. It made no sense to me that in Office Server 2010, the last one that I worked on, there was actually no jQuery component, even though Visual Studio 2009 had shipped with it. That lack of ability to adapt to new technological trends was really off-putting to me. And so I found a smaller group in Microsoft, one that had a startup mentality, called the Windows Gaming Experience team. And in 3 months, we built a platform for playing games inside of the Bing search engine. So you could go to Bing, you could type Hexic or any other casual games, and suddenly just play it right there. It never really caught on, and eventually the team got reorged into Xbox.com. But it gave me a real taste of working with a small group of people to get something done really quickly, something that I've kind of always valued. I didn't like working on Xbox.com too much, so I moved into Xbox Live, where I got to work on the sexy back end of moving all the metadata associated with Xbox Live content as publishers wanted to sell it. This is my first taste of big data, both in the amount of data you gather and the actual size of Xbox games is really big, so different meanings for big data. So then after a year in Xbox Live, InsideSocial came talking to me, and I had the opportunity to join them as an engineer. What we do is we help marketers quantify the value of their social marketing campaigns. So without InsideSocial and any other social marketing business, a social marketer will run a campaign and they'll be like, okay, before we did anything, we had 10 Twitter followers. Now we have 17. I got you 7 followers. And the CMO looks and they go, okay, well, what does that mean? How does that translate to my business? And that's the question that InsideSocial answers. Because the CMO doesn't care about Facebook likes, they don't care about Twitter followers, they care about purchased dollars, email list signups, accounts created, whatever it is you want your website to do, that's what they actually care about. So at a high level, InsideSocial generates unique URLs for each piece of content on a website and then tracks the progression of these URLs through the social stratosphere. And we can then tell you who's doing what on your site, who got them there, and how long it took them to convert. This type of information, I believe, is actually invaluable, which is why I'm at InsideSocial still. And the overwhelming feedback we've gotten from customers has also been really positive. We do work with some big companies, such as StumbleUpon, to express the value of their service to their users. So at a super high level, that's what we do. But most of this talk is actually going to be about really big bets. We're a very lean startup. We have 12 people now, but a year ago we had 4. We didn't have time to spend a lot of time making decisions and go a little bit down the road and be like, was that the right thing to do? Let's go back and redo things and whatnot. We just didn't have the manpower, the resources, the time, because we have competitors who are actively out there, and they're probably not, running in circles. So once we made our decisions, we kind of just pushed all our chips in the middle, like this graphic depicts, and went with it. So this is kind of a perspective on what these decisions kind of were. So the ones I'm really going to focus on are architecture, our technical stack, and how we store and process our data. So I'm just going to jump right into architecture. I've used an amazing tool to generate this super scientific diagram, which at this resolution is incredibly fuzzy. It saddens me. Okay, so let's walk through it. At a high level, we have users of our customers. The users' interactions end up in a short-term data storage facility. We have code that persists the short-term data store into a media-term data store. Oh, this is amazingly focused. The long-term data store, and then we detect new data. We move that to a data store where we actually run a bunch of queries, which I call analytics magic, and then we give it to what our product can talk to. I use the word product here because it's really customer-specific what our product happens to be. For some customers, it's, for example, StumbleUpon. They really care about number of users, number of Stumble users, number of deeply integrated users that have multiple page experiences on the site, and number that came from StumbleUpon. Their hypothesis is when I direct traffic to a site, the StumbleUpon users will have a deeper experience on that site than just those that happen to discover it by organic natures or search. So we help them deliver that. Others, a e-commerce site, will want a rich dashboard that talks about the various products, how they're moving on the various channels, and who's driving them in the bird. So I use product here, kind of in a hand-wavy term. We can talk about that later. Also, if there's any questions during this talk, feel free to speak up. I'm happy to address anything. There'll be also a question slide at the end with a big question mark on it.
What do you mean, detect new data?
So the way we move from our medium-term data storage solution to our active data store is a daemon that looks for the arrival of new data, and then it starts processing it.
Oh, okay.
Okay. So I will now talk about...
So, you mentioned that, so basically you have data at various levels cached and stored, and then part of the data is being analyzed and sent to someone?
Yes. So we gather data from all the sites that we happen to be on. We actually store the stream of data in a medium-term data storage, which allows us to rerun the events that happen to occur in case we experience some data loss, or in case our customers tell us they want stuff they didn't know they wanted before. I kind of skipped this part, but in the social analytics space, the biggest battle we fight is figuring out what to provide our customers. It's essentially what search engine optimization was 10 years ago. Those strategies and those battles have kind of been fought, and people kind of know how to optimize search for your particular service. In 10 years, we're going to say the same thing about social. And right now, there's a lot of ambiguity into what we need to deliver in order to give CMOs the information they need to make decisions with their marketing budget. And so we collect as much data as we can, we store it in its rawest form, so we can revisit those decisions and we can augment what we provide in our product to those people without having to give them as much information as we can. Does that answer your question?
Yeah, so basically the product is the analytics dashboard.
It is in some cases. In other cases, it's an email report. I don't like to use the word analytics dashboard anymore because we've hired a designer, and the stuff he does is more of a live data-powered infographic magazine than an analytics dashboard. So he's really taking you on a journey across this web browser and telling you, okay, this is what's happening, this is where it's happening, this is when it's happening. And so it's not like line charts and pie graphs, it's like most of your conversions happen on Twitter between the hours of 5 and 9 p.m. Suddenly it's like, okay, if I'm going to promote a tweet, I'm going to do it at 5 and 9 p.m. so I get the most bang for my dollar. It makes a lot of sense. But it's not a dashboard. It's a product.
It's a real time.
That's another slide. I'm going to punt on real time for a second. It's real time within a couple hours, but the times of 5 and 9 p.m. type, that is real time. Okay, so now we're going to start filling in some of these charts. Oh.
I don't know if I should ask right now or later.
You can ask.
So 2 questions. One was you mentioned briefly that InsideSocial happened, and as someone who's also sort of trying to get into the startup world and trying to understand how to get startups interested in you and vice versa, like how did that interaction happen? Could you talk a little bit more
Sure.
as far as you can talk? And then the second question is, could you talk a little bit about the technologies that you actually like, the actual technology you use for long-term, medium-door, so like sort of.
I will definitely talk about that at length. So I'm going to punt the second part of your question into the future.
Yeah.
How I got involved in InsideSocial was interesting. One of the founders I had worked with at Microsoft a couple years ago on the casual gaming team. He held me in high regard as an engineer who could do things very quickly at high quality without losing a lot from switching context. And so when it came time to augment the engineering team, he thought of me and reached out to me. At the time, like I said, I was working on Xbox One, and I had a feeling that the march to product for Xbox One wasn't going to be the smoothest transition for the engineering team. So I was happy to explore other options. But at the time that InsideSocial reached out to me, I was not actively looking for employment. Cool. Okay, so let's start filling in some of these circles, grids, and triangles. First things first, we're a lean startup. I'm going to say these words a lot because it's true. We don't want to own machines. We don't want to own racks. A cloud solution makes the most sense for us. Of the numerous opportunities one can take to move their technical bits into a cloud per se, we wanted one of the big ones. The big ones aren't going anywhere. They're not going to run out of money. They're not going to forget to pay their warehouse bill and suddenly your instances turn off. There's just a lot of trust that any of these names would provide. Secondly, there's a lot of services that come with these large clouds. Azure, Google, and Amazon all do an amazing job at giving you all the tools you need to run your machines without actually ever seeing them or spending the minimal amounts of time logged into any one of them. We actually evaluated all 3, and we were very fortunate to get credits on all these clouds. So the decision we made wasn't monetarily motivated. It was more the quality of the overall offering that each of these clouds provide us. And I could give you a large breakdown, but what it came down to was Amazon for us was just further ahead in the services it offered than Google or Azure. If we were going to go with a Microsoft stack, which this is kind of spoilers for the future, we probably would have invested heavily in Azure. But given the other decisions we were making at this time, Amazon just had a superior offering. For example, we use EC2, Route 53, RDS, S3, Glacier, CloudFront, in our day-to-day operation. There's numerous other ones about Elastic Cache, CloudWatch for monitoring. I could go through the Amazon services. There's about 20 of them, and they constantly add more. So they are heavily invested in the cloud services space, and they continue to do so. Google kind of puts everything in beta, nothing goes out of beta. It's kind of their way. So they do have an offering. I don't believe it's as comprehensive for our needs as the Amazon one. So the funny thing here is that all these services make you kind of predisposed to Amazon services. When you have a need, I'm going to try one of the Amazon ones first because we're already in Amazon's warehouses, we're on their clouds. So we had an interesting story with CloudFront, CloudFront being the S3-powered CDN service. We set it up. We were serving our code to our clients, to their users. And then we noticed, when we got the bill, that it was a lot of money for what we expected to be paying. So after reading the documentation, we found out that they had a monthly fee of $600 for each custom SSL certificate you happen to have associated with your SSL data. Since we were looking to pay a monthly fee of $50 to $80, this was kind of like, whoa, what's this all about? Because some of our customers do operate with HTTPS protocols on the sites they have when they're selling things, we needed to support custom SSL. So suddenly, Amazon's CloudFront does not meet our needs. This is actually kind of funny. We did a lot of research. Well, I did a lot of research. And MaxCDN and Cloudflare are 2 very competitive services that do the same thing, and they do it for less than $100. This is not my graphic though, so these two have been compared against each other numerous times. The things that we wanted most from our CDN provider was that it be powered by S3. That's where we decided our medium data store was going to be. We have all these files on it. We didn't want to migrate them to a custom solution or seed a cloud in any other way. S3 makes the most sense for us. We do need SSL certs. We need to be fast. We need to have a reasonable price, but we don't need to be super fast. The way our product works is it loads a JavaScript file that we host on our CDN whenever our user browses the page. If there's a 2 to 3 second load time, it's okay. It's not the best, but you're not going to be doing anything on the page like sharing or converting in 2 to 3 seconds. Faster is better, but we're not going to pay top dollar for less than a 200 millisecond response time when the 800 one we get with the service we went with is more than enough. So we ended up, and this is a semi-recent story, going with Max CDN. And the main reason for this was, while researching, I found another company that found themselves in the same spot as seeing these random $600 charges appear on their AWS bill. They'd written a blog post kind of outlining their transition process, and it made a lot of sense. So for us, it was really following the service. Cloudflare is known to be slightly faster than Max CDN, but has slightly higher costs. So the trade-offs just didn't justify that particular decision. And I pulled this today. In the last month, we've transferred 83 gigs of stuff. We're using caching. June 9th was a big day for us. We dropped off after that for whatever reason. I believe caching took into effect. We onboarded some customers that day, so that's what it is. Moving on, technical stack. There are tons of stacks out there. There's the main stack, there's Ruby on Rails, there's .NET, there's Python. Does anyone know what this stack is?
Has something to do with Node.
It does have Node. It is the LeBron stack.
What?
In honor of the recent conclusion of the NBA Finals, I've elected to include it in this slide, but it's LevelDB, BrowserFi, and Node. The LeBron stack. It was not actively considered amongst us. But so, we were making a bet on one of these stacks, and they all kind of service the needs, which are able to service HTTP requests. We wanted a community of active developers because there are, a handful of engineers at InsideSocial. We can't build everything from scratch. We need as much MIT license, or many MIT license components as we can possibly get our hands on, or we're happy to pay for licenses if it so happens to work out. We're not in the business of stealing code, we just don't want to reinvent the wheel. InsideSocial, one of the corporate values is transparency. We aren't open source at the moment, but we will be at some point in the future. And so having a stack that lends itself to getting the attention of the open source community was something that we valued. Engineering excellence is something I'm personally very passionate about, doing the right thing at the right time, not taking a lot of shortcuts. Stacks that you can do this anywhere, so it's really hard for me to really express what I mean by this, but there are some stacks that lend themselves more to using solid design patterns and frameworks than others. And so, lastly, it needed to be modern, because in order to attract engineers when we grew, you need to be working on stuff that's not, ANSI C from 1970. Languages have evolved over the last 40 years or so, and we should take advantage of that when we're starting something fresh. Even if you're the best Pascal web service developer in the world, the Pascal web service game isn't quite what it used to be. It was an ironic thing because of engineers like working on things that are fresh, new, sexy, and hot. And as sexy as writing code can be, we wanted to be able to offer that to potential customers so they could learn and they could grow while doing great work for InsideSocial. So lastly, the lesson that Who Wants to Be a Millionaire really teaches us is when you don't know what to do, you kind of ask the audience. So this is a graph of GitHub repositories since 2009 and the language that they're created in. You'll notice that only one kind of goes up. And I've chosen 2009 as that is the year where Node came into common use. JavaScript starts and just keeps going. All the other ones peak here and kind of drop down. If we extrapolate these numbers through 2014, I know, I lost my slide. I'm so sad right now. There we go. If we extrapolate these numbers to 2014, we can't actually compare them to ones before because it's only 6 months into 2014. You'll notice that Node and JavaScript are still growing. there are 78,000 packages available on NPM. That number grows every day. This is yesterday's number. But while picking the mean stack, go back a slide, Mongo doesn't make any sense for us. Express, Angular, Node all make a ton of sense, and they're very natural for us to use. But our data, when it's used and presented to our customers, is inherently relational. This user shared this item on this channel. This conversion happened. These are all tied together. It's not, NoSQL just doesn't fit after we convert our data and process it. So we've adjusted mean and kicked out Mogul, can't talk, I'm sorry, and added MySQL. I feel MySQL is eventually going to translate to Postgres for us, but that doesn't really hold up to the mean acronym. And MySQL's actually come a fair ways over the last 15 years or so, when it was just get some MySQL, get some PHP, mush them together and call it a website. For the purposes of our product, which doesn't do a lot of joining or subqueries, it's just a lot of selecting all the data that we generate for it, MySQL has actually held up really well. So I keep saying I'm going to change to Postgres or Oracle, or maybe that's the time to use our Azure credits. But in the meantime, not yet. So how do we do on this one? Well, NPM is actually kind of unreliable. It goes down randomly. It's actually been better as of late, but I've noticed, like, in its height, it would be down, like, once every couple of months, which isn't a big deal. But when you need to deploy your stack, it's really difficult when the package system is not there. You can check in dependencies to kind of work around this, but then you're loading your code base with code that's not yours, and it's really unnatural, and upgrading becomes a pain. Instead of changing the references, you have to change and check the source. So I don't have a good solution for that yet, but NPM seems to have gotten better as of late. Secondly, not all modules are created equally. Some developers, and since this is allowing anyone to kind of publish whatever they like, take their code really seriously. They write code that they expect to build products on, or other people build products on, and it's really ship quality. Other people, they have projects, they create them, they slap a release tag on it, and off it goes in NPM, and whatever happens, happens. I'm going to tell the story of Tim. Tim's an engineer we hired back in January, and he was tasked with building a Node app that would examine pages that our customers had, and just look to see if certain selectors were there, certain elements, certain class tags, whatever. We wanted to know if customers were changing their website and therefore breaking our ability to track the events that were happening on it. This seems reasonable. There were two modules that really did the headless browsing portion of this, since we didn't want to write our own headless browser. One of them, it had been about 2 months since anything interesting had happened in it. It had no external dependencies, but it had 174 open issues. The other one, it had been 3 weeks since anything happened, did have a really big external dependency, but only had 18 external issues. So my take on this was I told Tim to, if this module 1 with no external dependencies works, let's use it. Maybe the issues don't affect us. Maybe it's actually done, and the fact that it hasn't been updated for 2 months is okay. Tim kind of went with that, and he used that module. He coded against it for 2 days. And suddenly it just stopped working for some pages. Like it returned no HTML. It's not a very good headless browser if it returns no HTML, because there was definitely HTML on those pages. And so we had to switch to module 2. So we really didn't evaluate the module. We kind of trusted that, hey, it's released. Of course it's going to be great. Why wouldn't it be great? And so he actually, since it was his first week when he was doing this, he ended up working through the weekend to make a good impression. And actually I just wanted to teach the lesson of, hey, don't trust everything that's out there. Of course, about 15 days after we did this exercise and Tim kind of worked through the weekend to switch to Module 2, the owner of Module 1 kicked it into high gear and has been updating his thing every day, and he's down to like 15 open issues. So it's just bad timing for us. But the tale is, code is as good as it is, and you can't trust it all the time. So the reason we didn't like Module 1 originally was it had an external dependency. We can talk about that. If your deployment, or if a single new dependency is overcomplicating your deployment process, you're just doing it wrong. It's really easy to take shortcuts when it comes to engineering or anything in life. And when you do that, you accrue what we call technical debt, which means you spark up an instance, you don't really care what image is on it, you log into it, you copy some files, you start your app up, and bam, you forget about it. Well, until your instance crashes, it gets absorbed into the cloud. It doesn't happen very often, but it can happen. And suddenly you need to recreate this. It's really difficult for you to understand the steps that went into it, especially when some stuff is never checked in and just happens to be sitting in the cloud somewhere. So at InsideSocial, we kind of looked at ways to automate the deployment such that I can go to that very machine, type one command, and suddenly our web server is swapped out with a new one that has all the latest Ubuntu packages on it. We ended up using Ansible for this, but we could have easily used Puppet Master or there's one other one I forget the name of. But there are multiple options. As long as you're using one of them, you're doing it right when it comes to managing your software or your service. And when you do stuff like this, suddenly you can build an integration pipeline. Because you can programmatically create instances at like the snap of your fingers, suddenly you can have a web server that has your daily build on it, a known build, a known good build, and then the one that your customers actually hit. And then, if you have a bunch of test code, you can actually move between these auto-magically. So test code is the next thing, which adds incredible value when you have a product that has behavior that you want locked down. You don't want engineers breaking behavior that you know to be good. The engineers should be nodding because they know this to be true. InsideSocial has very little test code. This is another one of those big bets. The answer is, or the reason is, and the reason I can say these words and believe them and still have this, is because we don't actually have a product that people rely on that has behavior. We spent a lot of time figuring out which information to show our users, and this means that a lot of work has been done and then undone. We've had to redo things to optimize them for that, for what we want our users to see and experience. And if we've written tests for them, all this would just be thrown away. So as soon as we get to a point where we have people relying on a solid foundation for the information that we present them, we're going to write a bunch of test code. We're going to eat our vegetables. We're going to pay down this debt that we accrued. But until we have that, there's not value in people writing and specifying behaviors that may or may not be around in a week. So in order to best use our resources, we are punting on testing for now. But, as I tell the engineers on my team with a semi-regular basis, that it will happen soon. So how are we doing with test code? I mean, how is this affecting us? It's been okay. It's only going to be bad when engineers get careless and they break things or break each other, and it hasn't happened yet. So, with fingers crossed, we will live dangerously until July 2nd, which is the anticipated date of us being able to write a bunch of test code. Corollary to this is the code that we put on our clients' websites, the code that lives and interacts with their forums and their events. We do test that very religiously. I mean, multiple eyes looking at it, and the absolute worst thing we can do is break our clients' sites. If suddenly we go on their site and they can no longer purchase things, they take us off their site and they don't put us back on. We get really one shot at that, and establishing a solid foundation for being technical experts is something that we value. Bonus corollary is that you would be shocked how many brands and large companies that may or may not be in the area don't test our code before they put it on their production sites. They drop it in, they expect it to work, and if it doesn't, they're shocked. So it'd be nice to have a list of test cases we should execute instead of going through and manually filling out code or looking at compressed JavaScript to see what behavior matters most. But that's just not the world we live in. Any questions on technical stack, because we're about to move to storage. Alright, I must have explained things really well. So, there were 3 buckets on my architecture chart referring to storage. There was our short-term solution, our medium-term solution, and our long-term solution, as well as our data store. So starting with short-term. When it came down to it, we really had 2 solutions we were looking at, Redis and Aerospike. Requirements were, we had to handle lots of writes quickly. We can be on sites that get tons of traffic. We need to be able to record all the events that happen, and we need to be able to not fall over. We need to be able to serialize ourselves by some mechanism and restore state on separate machines. when we process our data, when we mine our short data store, we don't do it on the machine that's handling traffic. We empty that out, move it over, and then we detect that new data has happened, and we process it. And lastly, we don't want to do any of this by hand. We don't want to write shell scripts that interact with these machines. We want an SDK. We want a good development experience. So we know what functions we're calling. We know what objects we expect to get back. If there are errors, they're in the form of exceptions, not standard error messages. All of this is actually really key. For us, these two solutions were actually functionally equivalent. They both excel in each of these areas. So we flipped a coin. And that's not actually what we did. We, once again, asked the audience.
So what is the meaning of the second point you said?
The second point?
Yeah.
Which is be able to serialize yourself such that you can be serially sorted in the machine. So for us, when we have a bunch of traffic heading toward our short data store, we don't actually process that on that machine. We need to copy whatever's there, move it over to another machine that parties while still processing traffic, and then generate whatever data we need to from there. Does that make sense?
What kind of processing happens in the...
For us, it's like how many shares happen in this time period. How many insert product X were sold. How many people signed up for accounts. The conversions that matter. We get those from mining out our short data store and then looking at what happened in that block of time. So it could be page views, it could be random other interactions. Whatever our code that lives on our client's websites is recording is blocked into these these data blocks. And so when we process them, it's actually very intensive. And so we have to move it to another machine, which is why it's great to take the state of one machine, handle it on this machine that doesn't have active traffic, and then generate all the data and whatnot that we need.
Mm.
By the first machine, you mean the client's machine, or?
The first machine, I mean in the case of this, it's the AWS instance that hosts our Redis server.
So
And then we have AWS instances that process Redis data. They both run Redis. One just has traffic hitting it. The other is just driven by the arrival of these data blocks, or these data files in our short-term data store. Cool. So once again, we asked the audience, and in the case of these two, Redis and Aerospike, Redis is like a cult following in terms of memory living databases amongst developers. Aerospike, not nearly as much. So we went with the popular option, and we used Redis for our traffic management system. How did we do? 1 month after we chose Redis and made our big bet, Aerospike released a new version. This version is actually tested incredibly well when it comes to benchmarks against Cassandra and MongoDB. Unfortunately, there were no benchmarks out there that compare to Redis, but I suspect it's very comparable. Secondly, in December of last year, Amazon unveiled its Kinesis service. Kinesis, being an Amazon service, is supposed to be a short-term data store or a queue of events which would enable very rapid processing of data. That's what it's meant to do. If we'd waited till December to make our big decision, I have a feeling we'd end up on Kinesis. It's very likely we'll revisit this at some point in the future. These are more spoiler alerts.
Do you have any thoughts about RabbitMQ?
About RabbitMQ?
Or is it was it after you guys did the...
It was after. That's another one that could be on this slide.
Yeah, I know a lot of folks are now sort of switching from Redis to RabbitMQ. I'm not sure why that's happening, because I don't know either well.
I'm not well versed enough in that,
but
but I believe it.
Yeah.
I think we ended up with the most popular one, but the most popular one kind of is the most popular one.
Yeah, exactly.
So
because it used to be Memcached, right?
Yeah.
And then it moved to Redis, and now it's RabbitMQ is the hot thing.
I think you're totally right.
Yeah.
So I think if we were making a decision today, we'd end up making a very different one than we did over a year ago when we chose Redis. Having said that, Redis has met all of our needs. We used to be on the largest traffic aggregator in Egypt, and at the time we had Redis running on an AWS micro instance, which is like a third of the core, and you get it like every 20 minutes for upwards of 3 seconds before whatever else is on the instance takes over, and it handled it without issue. So Redis has been fine. I just think we'd go a different direction if we had this choice to make again today.
They're different systems, right? So Redis and all these are just NoSQL.
They are.
Like cache systems.
They are cloud hash tables.
Right. The RabbitMQ, I think this one is a message queue which is
You can use that as a cloud hash table, but it's how you handle your messages.
I thought you could also use Redis as a queue.
You can.
Because the elk stack uses that, right? Like if you use elk for log harvesting, centralized logging,
Right.
we actually put in a sort of Redis queue, that's what they call it. And then
Yeah.
your
You
log
can-
stack just picks up things from the queue.
You definitely can, and that's why Kinesis is offered as a queue service. The cloud hash table versus the queue, it's kind of in how you interpret your data. We can talk about that later if you want. I have no slides on it, but I'll happy to see with you after this. Okay, so last big decision is our data store. Amazon's Redshift was very new a year ago. Google's BigQuery service was less new. We actually evaluated both of these when it came to where are we going to put our queryable data. We generate a ton per day from all of our customers. We need to be able to run insights on it very regularly. We did a test of each of them. Redshift was unable to load our CSV file at the time. It saddened us, but BigQuery did, so that made our decision really easy. We had one system that worked out of the box and the other that didn't. Since then, earlier this year, March 25th, 2004, BigQuery has actually moved and made a bunch of improvements in both performance and cost to enable the processing of real-time analytical data. That's awesome. That's what we want to do. However, a UW study says BigQuery is very easy to set up and run queries and does not require any manual configuration of clusters. It automatically scales up according to the dataset size, but this can be a disadvantage as well since the user cannot tune the system according to his or her needs. However, it's limited SQL language support and does not scale up well on complex queries involving multiple joins and nested subqueries. So all of this means is essentially we've taken big data and we're going to easy mode. We've found the solution that generically worked. It does work, but it's definitely not optimized for our usage pattern. There are things that it's missing, which are full SQL support. BigQuery has no way for you to take a BigQuery table and remove certain rows from it. Delete from does not exist. In order to phase data out, in case we don't want to process all the customer's data with every query run, like because the data from yesterday, it doesn't actually change. We need to come up with new tables per day. We need to create those, or we need to expire tables. Either of those are kind of non-optimal, but that's the world we live in. It is priced very well, which is kind of what attracted to us in the first place. They charge us a modest storage fee for the data, and then they charge us for the data our queries touch as they generate the results. So as long as we're not going select star from everywhere, we actually get very cost-effective results. And at this point, it's NoSQL, and our data is actually still NoSQL. This is our conversion of NoSQL to SQL as we come up with the relations that all of the users do as they share the content on the various channels. So,
question.
Yes.
What's the UW study comparing BigQuery against? Is it like a regular?
I have a link. I think there's this. If I click on this, let's see what happens. I cannot locate internet server. I don't have internet, but I will send these slides out or make them available, and clicking on that link will answer your question. But it was a graduate study of the computer science department on comparing Redshift and BigQuery. And this is from the too long to read part of it, the results section.
So Redshift has a more expressive SQL language?
Redshift has full SQL support.
Oh.
It's essentially cloud-based Postgres, and so it does a lot of things that BigQuery doesn't do. But you need to tune it. You need to set up a cluster. You need to tune it to your data set, which is why I think it didn't work when we tried to evaluate it.
And what is the data removal and archival is not possible in BigQuery?
It's not possible in BigQuery.
So what is the downside of that?
Google will tell you there is no downside of that. I will tell you that the more data you throw at your queries, the longer they take to execute. We haven't noticed a substantial drop-off as our data sets grow larger and larger.